Okay, this is Team Bernoulli, and I'm Todd Wynn with Keaton Jeremio and Jose Rodriguez, and we're reversing engineering a wine bottle opener. The three mechanical components we're going to be covering on the corkscrew will be bearing, gear, and shaft.
The bearings we analyzed were these pins, which experienced pure axial loading and therefore would fail due to shear forces. The gears we analyzed are in a rack and pinion setup and would fail either due to contact stress or pitting or from bending stresses. The shaft analyzed was subjected to axial loading and would experience brittle failure due to excessive tension due to the material properties.
Using SolidWorks, we created a static analysis for the pin, gear, and shaft. We also created a fatigue analysis for the gear and shaft only. The material simulated was cast steel. The pin on the corkscrew takes on shear forces while the gears are being moved. As you can see, the loading we tested was large enough to rupture this pin. This gear is driven by a person pushing down on the handles. The unrealistic force causes the handles to bend significantly, but the gears are stable without deflecting. The fatigue analysis shows that with the large load that was applied, the gears will have an infinite life. This shaft is undergoing an axial loading that causes tension. The force applied is large enough for the shaft to yield. The fatigue test determined that it will have an infinite life.
So here's our failure modes, effects, and criticality analysis charge. And the component that is most likely to fail, which is the opener arms, it will fail due to bending stress. So for our mechanical improvements, the bearings, which is the pins, need to be strong materials to resist shear force, and the gears need to be flush for less impacts on the shaft, and the shaft materials need to be more ductile to prevent brittle failure. The hero.